Okay, I'm working on problem 4 practice 3.19. This was a problem a student asked in class today. And we started it, just ended up being a really long question. So to save some time, I've rewritten some of the work that we did in class on this paper here, but I asked for some extra time. It's just a long problem. So this is sort of, I would say, top tier for the exam. If you don't understand how to get formula weight, or you don't understand how to get density or moles, or how to name ionic compounds, those are sort of one level questions. This is maybe a 3 or 4 level or 4 or 5 level question out of 5. Okay, so but again, it's for practice problem, page 107. I'm just showing you the problem here, but I've interpreted it over here. One thing I didn't write on the board today was the word combustion. Okay, now we assumed it was there. But it is in the question. On page 107, you'll see that the question says, for the combustion of this compound, which only has carbon, hydrogen, and oxygen in it, we're going to take this mass of it, 0.8009 grams, and the question is, I think the question is, I better look at that again. What's the empirical formula? I think that's the question. What is the empirical formula? Okay, yeah, that's what it is. Now, knowing that, and this is some more things I wrote on the board, I said, all right, let's first of all define combustion. And combustion is defined as this compound. Again, I'm writing X, Y, and Z because I don't know what those ratios are, right? Combine with oxygen, that's just the definition on page 105. Combine with oxygen, give carbon dioxide and water. Okay? Now, how many of our carbons are here? That X, it's going to be here, right? I'm not going to say what that Y is. You can see that there's 2 hydrogens for every one here. Every carbon in this compound comes from this over here. So there's one here. There's going to be X of them over here. Okay? And Y, this is going to be either Y or 2Y or Y over 2. I think it's Y over 2, but I don't even want to think about exactly what that is right now. I just want to point out that all these carbons come from here. All these hydrogens come from here, right? Okay, so we just interpreted this, make some notes to ourselves. We found the mass of this stuff here was 1.6004, and the mass of water was 0.6551. The mass of this total was that. Okay. Now, be careful now. Some of this stuff is oxygen, which comes from here, so we can't simply say that this plus that plus gives us that. It doesn't, right? There's more oxygen in here. All right, but I'm still going to work my way down and find out how many moles are here. Okay. So that's formula weight of this. This was calculated. I forget who calculated this. I think it was Chris. I remember DJ calculated that one in class. It was 18.016 grams per mole. Right? So how many moles of water are we going to get? And how many moles of carbon dioxide? And we calculated 0.3636. All right? I think Patricia did that one. And I'm sorry to say I don't remember who did that one. All right? So we were all calculating those in class today. Well, this is just interpretation of the question. That's all I've done is interpret stuff. I've calculated formula weight, calculate formula weight. I've defined combustion, right? We've done a few things, but for this particular question, it's many layers to it. That's all we've done up to this point is interpret the question, right? But now for elemental analysis, which is what this question's about, the table I've shown is here. Sorry for the crooked line. The element, mass, formula weight, moles, moles, and moles. And that's how we figured out the empirical formulas, okay? So the mass of carbon here is not 1.6004. That's the mass of carbon dioxide. So what I've got to do is I've got to figure out the mass of carbon. And the mass of carbon, I'm going to do this in a separate sheet of paper. It's going to be grams of carbon, and I'm going to get that from here. Right? All that carbon came from here. So the grams of carbon is going to be grams per mole of carbon. Here's my grams of carbon. Right? And I've got to relate my moles of carbon to moles of carbon dioxide. Right? And that's going to cross off with that. My moles of carbon dioxide, I've got grams of carbon dioxide here, right? So I've got to relate it to that. Moles of carbon dioxide, grams of carbon dioxide, and grams of carbon dioxide. This is just my given. That's my measurement. These are going to cross off, those are going to cross off, and boom, I'm left with grams of carbon. Perfect. This is a relatively challenging conversion problem. It's its own standalone. You're going to get a problem like this on the test. This problem is worth just as much as that problem there, right? Even though this problem is made up of a bunch of little ones. All right, so how many grams of carbon dioxide did we have? We had 1.6004. How many moles per gram? Well, typically we say 44.01 grams per mole, right? How many moles per mole? Looks like it's a 1-to-1 ratio. And how many grams per mole? 12.01. 12.011 depending on your periodic table, right? And that's going to give us the grams of carbon. And we'll put that here, right? So remember, going back to the question, we have this mass of this stuff, and 0.8009 grams is all of these things. So I'm going to find the grams of that and then the grams of that. And the rest will be, of course, oxygen. So I'll figure that out in a second. Let's set up the grams of hydrogen. Grams of hydrogen, we're going to set up the same way, is equal to grams of hydrogen per mole of hydrogen. Boom, boom, right? Moles of hydrogen per moles of this stuff. H2O, those will cross off. Moles of H2O per gram of H2O, right? Because I'm relating it to grams, because that's what I was given. Those will cross off. And then grams of H2O, and that was what I was given. That's my measurement. These are conversions. That's a measurement. So it looks like that was 0.6551. Hope this is on camera. And this was 18.016 grams per 1 mole. How many moles of hydrogen per mole of water? Aha, that's a challenge. It's 2 to 1, right? There's 2 moles of hydrogen in every 1 mole of water, because it says right there 2. So it's 2 to 1. And then grams is 1.008. Okay, and that's going to give us that. So let's calculate those numbers. 1.6004 times 12.011 divided by 44.01 gives us 0.43677. 0.43677. Okay? And we'll calculate the moles of that in a second. By the way, you see, again, remind you, that is the moles. Whatever moles we have of this stuff is the moles of that. Okay? That's 12.011. We'll calculate that in a second. Now the moles of hydrogen are what? 0.6551, 0.6551, enter. Okay, this comes out to be 7.2847 times 10 to the negative 2. Okay, now you remember now, right, that the sum of all these was 0.8009. So if I take 0.809 and subtract those, this plus that, right, that's a sum problem. If I take this number and subtract those two out, then I'm going to get the mass of oxygen. Okay, so it looks like the mass of oxygen was 0.29128. Okay. Awesome. Hydrogen, now we're going to just go across the table like we have before in elemental analysis. We're going to find out how many moles, the mole ratios of these. That's 1.008 grams per mole. This is 16.00 grams per mole. Alright, and I'll take this and divide it by that. Oh, by the way, you should check these numbers. Add these three numbers up and make sure you get 0.8009. Okay. I'm going to take this one first, because it's still in my calculator. This ends up giving me 1.82 times 10 to the negative 2 moles. I'll divide these two now. 7.23 times 10 to the negative 2. What about these two now? This gives me 3.636 times 10 to the negative 2. Okay, now I have to divide all these by the lowest number. That's going to go to 1. I see that's the lowest number. This is going to go to 2. And this is going to go to 3.97. Okay, and I can see, I rounded here, folks, by the way. If I'd have kept all the numbers in my calculator, it would have been more precise. This goes to 2, that goes to 4, and that goes to 1. 2, 4, and 1. And so the empirical formula is C2H4O. And that is the answer. All right, several layers there. Hope that's not overwhelming. Don't forget, we had several standalone problems here, including how to find the mass of carbon in the mass of carbon dioxide, the mass of hydrogen in the mass of water. And that was probably the biggest challenge right there, just relating the mass of those. And I knew I had to do that because when I do elemental analysis, I'm going to be going from my masses, right, and finding the mole ratios. Okay, good luck.